We're trying to figure out the shortest distance between two skewed lines. First of all, what are skewed lines? Let's understand that. So for that, we're going to make use of the following. So guys, as of now, how does this set of lines look like? Are they intersecting or not intersecting? They look to be intersecting, right? They look to be crossing each other, touching and crossing each other. But if you examine it closely, we can clearly see that they are not intersecting. Agree? They clearly are not intersecting. There's a clear gap. So such lines which are not intersecting and are not parallel in a three-dimensional space, this is possible only in three-dimensional space, right? So such lines are called as skewed lines. We are trying to find the distance between them. So there has to be a distance, that is the minimum distance between them. Of course, if you take any other point over here, like at this end, at the corner, for example, they have to be infinitely long. But anyways, what I'm trying to tell here is, as in when I take the distance between any two random points, obviously that won't be the shortest distance. There has to be a particular condition and a particular set of points from both the lines, from where to where we find the shortest distance. Okay, now let's start off with the derivation. Before that, let's see what information you can be given. Well, we can get in two forms. One is equation form, another is Cartesian form, or direction ratio, or direction cosine. So Cartesian form and direction ratio, direction cosine, the formula is kind of lengthy. This is kind of simple. Idea is fun over here. So first thing is, let's draw a diagram to help us. Let me think of a line like this, I guess. And another line. Yeah, I think that would help. Now, say this is our, let me label it as well. That's our L1, or say L2 itself. And say that's our L1. Now, what is A1 and A2 over here? Let's understand it part by part. A1 and A2 are rect. They're points on the lines. Say something like this, and maybe not over there. Yeah, this would suffice. And say something like this. So that is our vector. Actually, their position vector pointing to 2 points. So on the lines actually. So A1, this is A2. And say this is B and that's A. Right? And what is B1 and B2? They are to do with direction. Is it not? This have to do with direction. Now let's consider, say this random point, something like this, to be our shortest distance. So say PQ. What is the condition for a line to be shortest distance between two different lines in terms of angle? Think about it. So let me continue with the derivation. You guys can think about what is the condition under which PQ will be the shortest distance. So let me start off by talking about, let PQ be shortest distance between L1 and L2. Right? Now we have to figure out PQ's length. So length of PQ will be equal to, let's think, how can we figure it out? See, what we know here is the length of AB. Again, AB can be in any orientation, anything, all that is okay. But how can we find PQ from this information? What if I give you guys the direction of PQ? How can I use the direction and the length that we know? Say we know AB. AB is a vector whose magnitude and direction we know. So we know this line, and also we know a line which is perpendicular not perpendicular, sorry, parallel to PQ. Can we make use of something? So first of all, how do we find the perpendicular or direction of PQ itself before talking about all of this? Okay, if it sounds confusing, let me put it in this way. So you can find the length of PQ by finding the projection of AB in the direction of PQ. So what I have here is two lines, and say this is some random line and connecting the two lines, and say this is the shortest distance. This is the shortest distance. This is a random line. I mean, the length we know. So this is supposed to be a bit shorter actually. Let me try doing this. Okay, that's better. So we know this distance. We have to figure out with this information and the direction of this, we have to figure out the length of this particular line, shortest line. So what we can do is we can take a projection of this length onto this, given the direction. We can take the projection. That is nothing but your dot product. Okay. So basically, we need to know the direction of PQ and take a dot with vector AB. And that's it. So how will you figure out the direction is what we have to figure out first. Direction of PQ. All this is okay. How can we find the direction of PQ? For that, we have to come back to the question of how is PQ related to L1 and L2, other than it being shortest distance in terms of angle. It has to be perpendicular. Now, the next question is, if I know B1 and B2, that is the direction of the two lines, how can I find a line which is perpendicular to both of this? Yes, using cross product. So basically, direction of PQ, you can obtain it by taking the cross product between B1 and B2 vectors, divided with B1 and B2, the magnitude. Right? Since we just want the direction, we'll divide it with the magnitude, making it a unit vector and nothing else. And next is we have to figure out AB. How will we find AB? Vector AB is nothing but, have a look at it. We have to find AB. So it would be A1 minus A2 or A2 minus A1. Yes, it is A2 minus A1. So triangle of vector addition, A2 minus A1 will give us AB, right? This is as per triangle law of vector addition. And finally, we have the PQ. So I need some space. And finally, therefore, PQ is equal to the length, that is the dot product between this particular expression and this expression. That's it. So P1 cross P2 divided by the magnitude of P1 to P2 cross product between B1 and B2, that is dotted with A2 minus A1, open and close the brackets. So we have the magnitude dot the direction with the length which we know of, and we'll get PQ, as simple as that. I hope now the concept is a lot more clear. Now, what if we get the Cartesian form, this being the Cartesian form, or direction ratio or direction cosine? Well, the formula is very lengthy, so just keep it up. I mean, just keep that in mind. It has to do with the cross product and all of that. We can do it step by step, but as a whole, there's a direct formula. I'm just writing it. So in the numerator, we have to find the determinant of the following set of expression, x2 minus x1. So where does x2 come from? From from the line 2, x1 comes from the line 1. That is the point whose information we know. Basically A1 and A2 basically. This has to do with A1 and A2. So this 2 has to do with A1 and A2, and this 2 has to do with A1 and A2. And this has to do with A1, B1, C1. It has to do with the direction, ratios, A2, B2, and C2. And this entire thing has to get divided with now the denominator. See this, it's similar to what we just did. Okay, we can derive this particular all this expression from the above result actually. But anyways, let me continue. B1 C2 B2 C1 the whole square plus C1 A2 minus C2 A1 the whole square plus A1 B2 minus A2 B1 the whole square to the power of half. So this is the entire funda. Actually, this is not funda, this is something that we wrote directly. But yeah, the derivation per se is not there, but we can actually derive it using the concept we already know. Okay guys, so the first point, the whole idea is to do with finding the projection of dot product between PQ and AB. So finding the dot product between PQ and AB, but we have to figure out PQ's direction itself. So PQ's direction, we can find it with a cross product. That's all. It all depends on the dot and the cross. There's nothing complicated over there. Right? Okay. Now pause and copy it off.